We have been looking at demand, but it's good to mention a few things about irrigation demand. One, because irrigation demand is important in terms of water use, but second, it's because also the techniques can be different. What we look at is factors affecting irrigation demand quickly, and also the distinction between effective and actual water use, which is related to what we were saying before about return flows and so on, and also about irrigation technologies. Choice of irrigation technology, I want to say a couple of things there, and then give you an idea of how to do demand modeling. One of them we have already done. The production function approach is what we said you could do if you optimize profit, because it's the same thing. So really what I want to discuss is the mathematical programming stuff, is what I want to give you some ideas about. So irrigation water demand is a function of many things: land quality, or how productive the land is, output prices like we were saying before, technology. And the technology is important because that's going to affect how much water you need, and input costs. So input cost, capital cost, is very important if you are using irrigation water, but also variable costs like fuel and so on. So two ways to model it. One is the standard, which is use a production function, however you get that production function, or mathematical programming. Mathematical programming, like linear programming, is the second one. So if you have a production function, nothing new, you use your production function. The only thing is you need to distinguish between effective water and actual water. So what goes into your production function is actually the effective water. It's not the water that you apply. So if that is different from effective water, then it matters. Depending on what type of irrigation you use, the two could be different. So if we do that and maximize profit, we can find out what the optimal water demand is, as we were doing before. And at the end of the day, what's going to happen is we are going to use water such that the value of water to us as a producer, which is the marginal product times price, is going to be equal to the cost of water. So that the value marginal product equals marginal factor cost story in production economics. How do we estimate production functions? Well, econometrics is one, but if you are doing simulation like EPSIM or something, people simulating growth of crops and so on, they could also have other ways, or bioeconomic modeling, which might combine things. So just a quick example there. If I have a production function, now this production function is what? It's not Cobb-Douglas, it's something else, quadratic. So if you have that, you can optimize, which is much easier to do. Then you end up with a demand for water. Does this seem a proper demand function? What should a proper demand function be? What's a well-behaved demand function for water or input? Of course, by definition, a demand function, the minimum it should do is it should be downward sloping. Okay, when the price of water goes up, it should go down, and that's what this one does. What else? Yeah, you got to be careful now. This irrigation and not consumption, so you can never be sure. But it also means the output price going up means you demand more water. Outward shift in demand. So that's just a quick example. Irrigation water demand depends on water price. What else would be interesting? Well, farmers are not choosing how much water to use when they are doing irrigation. They are also choosing a technology. So what is the common complaint about irrigation technologies? They are inefficient. What do we mean by inefficient? Why do farmers keep doing that again and again? Why can't they just do something more efficient than something that appears to waste water? Well, for them, it's a business decision. What it means is, just like I consider the cost of water, I am going to consider the cost of the new technology, including its purchase and maintenance. And basically, I'm going to optimize the choice of the technology. So the only reason I would have a more advanced technology is if that's more profitable. My probability of adopting efficient technology is going to be dependent on a lot of things. But if you think of the price factors, one of them will be the price of water. Because what does the efficient technology do for me? It saves water. Okay? Does it pay for itself? And of course, I don't look at just the water price, but I also look at the price of the irrigation technology itself. How much it costs to buy, how much it costs to maintain, and so on. So that's what I'm going to do. In economics, what do we use to do stuff? We use econometrics, right? We use maths to do a lot of our stuff, calculus, so on, linear algebra, but mathematical programming is also very important. And mathematical programming is something that economists have developed over the last 80, 70 years. So linear programming is a type of mathematical programming. Mathematical programming is more general because it can be nonlinear programming as well. What are we looking at? Well, these are techniques for optimizing something. That something could be your objective function, as they call it, which could be profit, which could be minimizing cost. It doesn't matter what it is, okay? Whatever it is, it's a way of optimizing something subject to constraints. And if the objective function and if the constraints are linear, which is the most commonly used method, it's called linear programming. If we look at the key elements in mathematical programming, to use the language of mathematical programming, you have what's called choice variables. These are the variables that you are choosing. Okay, so if I am a farmer optimizing profits, then I have things that are going to be my decision variables. So another name for choice variables is my decision variables. And you have the function you optimize, which is an objective function. It's called an objective function. And then, of course, you have the constraints. And if I am optimizing farm profit, what am I choosing? Well, type of land use types, crops, pastures I should have on my land. What type of inputs? And subject to what are my constraints? Well, my profit is constrained by the amount of land I have, unless I have a renting option, and I can do that. And of course, what else could I have as a constraint here? Well, you don't manage the farm year by year. You worry about the effect of what you do with your land this year or what you could do next year, right? And the year after. So it's dynamic. Crop rotation stuff, you can also write that in. So to solve mathematical programming problems, you need to identify a range of possible activities, which is the choice variables, quantify their economic and resource use characteristics, which means how do your activities go into your objective function and your constraints, and then use an optimization model to select the most economically optimal levels. If you want to get the demand for water, then you would do that for different prices of water to figure out what the optimal demand is at the different prices. So most effective way to see what happens here is to use an example. Suppose you have 5 different crops and you have 1,000 hectares and you have some other constraint. To make it interesting, let's say crops 4 and 5 are grown in rotation, which means what was in crop 4 this year has to be in crop 5 next year and so on. So they have to be alternating, and water costs something and the price is P. So what are our choice variables here? How much land to allocate to the different crops. And we need to know how much water each crop uses, because water is part of the story, and how much net revenue we make from each land use. If we do that, then we can have this. This is our mathematical programming problem. So it's easy to describe as an equation. HA1 is the land I allocate to crop 1 and so on, and the coefficients in here are the net revenue. So if I have this, I know depending on how I allocate my land among the 5 crops, I am going to get net revenue, but then I have to also subtract the cost of water. Cost of other things is netted out from the net revenue, so fertilizer and so on is already taken out. Subject to the land I use for production should not exceed what I have, which is 1,000. Crops 4 and 5 should be alternating, and here is my water demand function. Okay? Depending upon how many hectares of each crop I have, crop 1 needs 4 units of water per hectare, crop 2 3.4, so all that added should give me the water I need, which is what I put in here. Okay? So it's easier to understand this if you just put it on the other side. Water demand depends on land use. If you do that, you can solve that. How do you solve it? You can solve this in Excel. There is solver in Excel, but when I teach, I encourage people to use GAMS, or General Algebraic Modeling System. This is a set-based or matrix-based, very effective. You can write massive models without having to write thousands of lines of code. That's not the end of the story. You can solve it online because there is a public service called NEOS. You can just send your problem there and then you get the solution, which is very good. Okay, so mathematical programming, if you do that, then you can work out what the demand for water is. You can make them complex depending on what problems you have, and mathematical programming is very powerful. If you are a consultant and if you are doing real economics to advise people, you would probably end up using that because that's how you are going to work out what farmers will do if something changes. So for example, if I give farmers an incentive to cut back carbon, okay, carbon credits for example, how am I going to work out what they do? Well, you build a mathematical programming problem. One of my PhD students wrote a paper using this method to work out the carbon abatement costs among farms. And what he found is that the carbon abatement costs were somewhere between 20 and 30. And livestock farmers had lower costs, obviously, because they have more options than crop farmers. So these are very good methods. Okay, that's all I have to say for today.